I'm Pavel Ledentsov, and I'm after Fastnetmon, and I'm CTO of Fastnetmon Limited. Today I would like to talk about ways how we actually can filter out traffic, malicious traffic, which is coming to our network using our own equipment, even if you have no DDoS scribing equipment in place. Looks exciting, isn't it? So in previous videos I covered topics how you actually can stop DDoS attacks for immediately affecting your network. I had explanation about BGP black hole. It's first level, first frontier of your DDoS mitigation and defense. Next option I covered DDoS scribing, because it's one of the simplest ways how you actually can cover you from DDoS attacks, even if you have no specific equipment in place, and if attack exceeds your upstream capacity. But what else? What options we have? And for many companies and for many people, next level will be to buy expensive black boxes from DDoS filtering vendors. And because of their cost is outrageous, I would say. I was in this position back in time. I had my very first company which was focused on cloud compute. We had plenty of conversation about like how much we can expand from our budgets for DDoS filtering equipment, and in all cases the cost was outrageous. So unfortunately for so many companies it will not work this way. But what we can do, there is a great protocol called BGP Flow Spec. You may find that using RFC 5575, and if you want to hear more details. And what's exciting about BGP Flow Spec, because BGP Flow Spec, it sounds complicated, because problem is it's not about flows. Like an original name of this protocol is actually quite old. I had a different presentation about history of this protocol and well described explanation about what kind of quirks we have, what level of support from different vendors we have. So please find this presentation and check more details. I won't focus about them here. But great things about BGP Flow Spec. Again, it's not about flows at all. An original name of protocols flow specification. Again, misleading. What is specification? What kind of flow specification? Because it may feel like, is it about net flow? What are we going to do with flows? Again, let's step aside. So it's really, if you start continuing conversation about why flow spec protocol called this way, it will not end up well. So what we can do is BGP Flow Spec. What is BGP Flow Spec? Simple, in well-known terminology. It's protocol to manage distributed firewall. End point. What does it mean? It means you can manage multiple firewalls using this protocol and keep them consistent. I'm not aware about any specific protocol to manage firewalls. Again, I mentioned firewalls, but firewalls is a specific box for filtering traffic, and previously I had many notes about firewalls which actually may degrade your performance of your network instead of making it more secure. And when I say firewalls, it doesn't mean that it will be a specific firewall, because your router may act as a firewall. Great. So we're moving little by little. So BGP Flow Spec is a protocol for managing distributed and firewall, and which means it's just protocol to propagate filtering rules, or it's just protocol to propagate ACLs over multiple devices. I think so far it's simplest explanation. It's protocol to keep multiple devices in sync about their ACL. Because typically when you create an ACL rule, like drop all UDP traffic from port 53 using fragmentation, done. And you have 100 devices in your network. Not fancy. You need to repeat and make it 99 times more. It's boring. Of course, we may have some automation for it, but again, it will be vendor specific. And for every single vendor, for a new model from same vendor, you will need to, again, you need to rework it, and again, you need to patch it again. If it's like command line integration, you need to update it all the time when your vendor changes schema. it sounds like not fancy game, and all kinds of things which are not well covered by standard end up this way. And DDoS attack mitigation is very complicated area. It's very error prone because you need to make so many changes in your network and you need to do it fast. Because typically when you apply configuration changes like for ACLs, it may be just request from your security department, like which was prepared in like for months, and then you just need to apply it in quiet environment. But DDoS attack is something right now, immediately, which everything is buried, everything in hell, everything is like down. Your network doesn't work, and you need in rush to apply changes on hundreds of routers or switches or firewalls. It doesn't work this way. That's the reason why we need standard. And BGP Flow Spec is a really great standard for doing it. Why it's BGP? Why on earth we have BGP here? Because BGP is about prefixes. Like, we can announce something, we can announce specific community, but what we are talking about is to manage firewalls. Step aside, BGP is extremely flexible protocol, and I completely agree about using BGP for flow spec delivery, because it's great protocol, it's a really great transport protocol, it's protocol we have many people who actually understand how it can be run. And it exactly works this way as we need for propagation of filtering rules. So when we make BGP announce for a unicast, it will be immediately propagated over like our network, or upstream and internet in general, and so great. What we need to do with BGP Flow Spec, we need exactly the same. When we create a rule for filtering like alt UDP traffic from port 53, you need to have exactly the same rule almost instantly on every single router in your network. And BGP protocol can do it very well, because BGP protocol has consistent support for timeouts, it has consistent support for different types of relationship, for filters, like which router can accept it, which router cannot. We have logic for actually validating that what they are asking for, you authorize it for it, you have full rights for it, you have authority for this specific rule, and you can do it. So, sounds nice. So you have BGP Flow Spec protocol, which actually can be used for filtering traffic. It's exciting. And so, but reality is more complicated. Because it's not enough just to propagate changes, what kind of traffic we want to filter. I mean, that's what I said, like, there are two parts of BGP Flow Spec protocol, because BGP Flow Spec protocol can be implemented only using crowd reflectors. So, when you create some specific announce, it will be delivered to every single device on your network. But it's not expected that every single device on your network may actually apply flow spec announces. There is a great difference, there is a great complexity, because you may find multiple BGP daemons like GoBGP or BIRD or FRR, and actually they can receive flow spec announces, they can craft BGP flow spec announces, but it doesn't mean that they can actually enforce them. What I mean by enforcing them, it's actually implement filtering. I mean to work as firewall and filter out some specific traffic as requested in flow spec. That's why BGP Flow Spec is quite interesting protocol, because it actually requires that you have hardware support for large-scale filtering capabilities, which means that your router can can do it in hardware. And because if you try to do packet filtering in software, it will not end well, because it's really a compute-intensive operation, it's a very complicated operation. And that's the reason that you may find BGP Flow Spec support only in carrier-grade routers. When I say carrier-grade routers, I mean it's Cisco ISR 9K, Cisco ISR 1K, it's Juniper MX series, it's Nokia, it's Huawei, it's Arista, it's Extreme Networks, but mostly I'm talking about one of the top performant models, which expected to work in carrier-grade networks. So most of the time you don't expect support for BGP Flow Spec from your software router, don't expect it from your a MikroTik. Don't expect it from entry-level model even from Juniper or Cisco. It will not be here. Some routers or software, like for example, virtual edition of Juniper MX, they may have support for option to receive BGP Flow Spec or craft them, but they cannot filter it out. That's a main problem. So to implement BGP Flow Spec, you need to have carrier-grade hardware router. It's quite harsh requirement, I would say, for many companies. It's out of their budget. But for most of the networks, it's great. Because for example, for Fastnet one of the most popular routers, it's MX204. It's really great router. And so many customers are happy about it. It has a great support about options to route traffic actually. So because it's a reason why you need router. But on the different side, it has great support for telemetry. It has great support for BGP Flow Spec. It's exactly what we need. So very likely that your router have it, or your router may receive it in next version of firmware upgrade, which is happens, for example, for Arista or Extreme Networks. And so many vendors, they consider BGP Flow Spec as really a useful addition. And for many, even largest telecom providers called Tier 1 providers, many of them, I wouldn't say all of them, but most of them, they have support for BGP Flow Spec. It doesn't mean that they will allow you to create BGP Flow Spec annonces, but they have it for their own purposes. And it's great. It's a way to confirm that this technology, even if it works for them, it will work for you. So, and what you can do with BGP Flow Spec? You can do many things because it's BGP. It can propagate changes almost instantly to every single router in your network. And you have routers already, and they can process serious traffic. They can process lots of data and very fast because they built for it. And it means they can drop traffic very efficiently, which is great, which is exactly what we need. So as we move away from ideas that we cannot use, that we can use black hole to block specific IP in our network, we move to the idea that we can actually filter out malicious traffic. And for example, if we see like malicious traffic coming from port 53 UDP protocol, this fragmentation, and at the same time we see that this service receives lots of traffic over port 443 using TCP protocol, and it's definitely not malicious, it's expected, it's normal, it's main point of this service to process this kind of traffic. And you can create specific BGP Flow Spec announce to filter out only malicious traffic. Because in many cases, if you create something, in case of anything, just drop UDP. It will save you from maybe 70% of DDoS attacks. And if you know for sure that your service is not using UDP at all, again, it's quite popular because still scope of using UDP protocol is very limited to protocols such as DNS, NTP, or maybe SIP. Of course, latest version of HTTP protocol uses UDP, and I wouldn't say that I'm very happy about it personally. But you know for sure that your service uses it or not, and even if you use HTTP3, you have an option to switch it to HTTP2, like for now under DDoS attack, because protocol can handle it gracefully. You will lose some chunk of customers, some fraction of customers in this case, but most of the things will work. So BGP Flow Spec is a great protocol, but of course every time when you deploy complicated technology, and BGP Flow Spec is indeed, it's way more complicated than you can imagine, because even routing of BGP protocol is complicated, but BGP Flow Spec adds options, not only adds prefixes, but it also can operate source port, destination port, protocol lists, different flags, like fragmentation flags, TCP flags. And so you can do many things, and you can do many things wrong. So be very careful, and all the time when you deploy new technology in your network, you need to be extremely careful. But I would say BGP Flow Spec is very mature technology. It's very old for now, and for more and more vendors they add support, and even for some vendors they support it in hardware level. I mean, when you announce, for example, for Arista, I think, or no, I may be actually wrong. I think it's more about Extreme. When they actually create BGP Flow Spec announces, it actually just converts them into ASIC filtering rules in silicon. That's all. It's implemented by microchip, and then it filtered out on line rate. Of course, it has some constraints. It doesn't mean that you can create thousands of flow spec rules and expect it will be work as perfectly fine. No, it will not in most of the cases. You need to be very careful. And different idea you may have, because I mentioned BGP Flow Spec is a protocol to use to propagate ACL between routers. But I would warn you that never ever you should use Flow Spec for static rules. So if you want, for example, to block ICMP protocol completely for your specific service, you need to use your ACLs, old-fashioned way, deploy it via any different way of automation system you have in place. It's not for BGP Flow Spec. BGP Flow Spec is only for highly dynamic, short-term filtering rules, which can be deployed on, for example, for minutes, maximum tens of minutes, maybe hours, but no more. If you have something static, you need to keep it in just your configuration. It has nothing about BGP Flow Spec. BGP Flow Spec is for something you need to do now, and it's not expected to have large number of BGP Flow Spec rules. So under no circumstances, unless you operate in normal network or you're a tier 1 operator, which I'll be happy if you're listening to me. And in this case, and for normal circumstances, for averagely sized network, you may not need more than tens or maybe up to 100 of BGP Flow Spec filtering rules, because typically you need more of them if attack vector changes significantly, but for many type of attacks they're quite dumb, fortunately for all of us. And so they can be filtered efficiently using 5-7 rules per specific IP address. It may be some specific flags, some specific packet length, some specific source ports, or fragmentation flags. Not so many of them. So of course, in Flow Spec you must not ever care about what was source IP of attack. Never ever. I warned in previous videos that you need to ignore your idea, okay, I can block attacker. You cannot, unfortunately, because there are tens of thousands of them, millions of them. In many cases, they're spoofed, they are not real, they can do something else, they can pretend they are, for example, they're coming from Google, and then you will block Google. It's not what you're looking for. So that's the reason why source field is available in BGP Flow Spec, but there are no reasons to use it actually, unless you're absolutely sure that attack is coming from this specific /24, and you can actually do a blocker. But it's only one case, and when you're absolutely sure. In all other cases, you need to care only about destination IP. And different thing is, when you want to create Flow Spec rules manually, you need to limit their scope. Otherwise, you may create rules something like, I see some weird traffic on port 179 over TCP protocol. Let's block it in our network. It will not end well, And that's the reason, it's not expected for everyone to know that this stuff is really important. It's really important, it's crucial for network. It's more about, you need to limit scope for every single change you make. Everyone can make mistakes. You may be in attempt to block maybe protocol port like 17, and you accidentally click it 9 and press it, and then you have no way back. That's the reason why all the time I recommend using scoped Flow Spec rules. All the time, if you see this attack against specific host, add scope for Flow Spec rule, and never ever apply it on all your network, because you need to be more specific. Their router, can you drop fragmented UDP only for this specific IP, because there are no reasons to do it on all your network. Or really, there are no reasons, because you may create more harm, and it may cause more harm to the attack itself. So, and as you can hear, BGP Flow Spec is a really great protocol. It's really complicated to craft rules by hand, and in my next videos I will cover how a connection automated. Thank you for listening. Goodbye.